Good morning. 10 o'clock is 5 past, so now we'll start. My name is Torstein Bø. I'm a senior software developer at Sintef Ocean, and I've been during the last year developing this implementation that I'll have a walkthrough today. It's actually the second attempt that we do on making an open source implementation. Yeah, so we've taken a lot of things we learned from the first attempt and now improved it a bit. So I go straight into the details. In this talk, I will be talking about many different projects, which is in the same GitHub repository. So that's just to clarify. Here are the different projects. So the main project is OpenBridge Web Components. That's the web component library written in Lit. Then there are two wrapper libraries called OpenBridge Web Components View and OpenBridge Web Components React. These are auto-generated wrapper libraries for Vue and React. I also see that Google is working on Angular wrapper, so that will come later, I think. And then we made a Vue demo, which I'll talk about next. And there is also a React demo to show how to use this component library for React. So here is, see, I get a question in the chat if I will share the presentation afterwards. Yeah, we are recording the presentation. So we will share the recording of that. Yeah, so here is the demo. It's available at the openbridge-demo.web.app. So there you can see the live demo from the main branch. So why did we make this demo? There are multiple reasons. The main one was to start the development of the open source implementation of OpenBridge, start getting to use the components and see the components in an application, not only as single components. Then we would like to test the implementation in a production-like environment. We see that the developer experience, how easy it is for the developer to use the components, is very important. So therefore, we would like to get the feeling of how to be a developer using this library by making a demo. So in a similar way that you will make a production application. We also use this demo for designers, for Kjetil and the entire OpenBridge crew, to test the components in a more realistic context than Figma is possible to do. And we also made this demo so that you can change the content and replace the content by iframes. So the idea is that you can use iframes from Figma and put that in as apps here. So this is the demo app. Here I show the palette shifting. So we do palette shifting as earlier. We use CSS properties, which are set on the HTML DOM. And yeah, we have also used Firebase as a real-time database here. So here you have two different windows open, and then they sync the state. Now you only can sync the brilliance and the palette state. So it's done by setting the bridge ID in the URL, as you see in the navigation menu. And if they have the same ID, then they are on the same bridge and share the same states. If you have any question, just write in the chat now. Or try to explain or answer the questions. Yeah, we are also implement a lot of other features like the alert menu that you see here, the app menu, and navigation menu. And for the alert, we have also the possibility to simulate alerts. If you click this alert simulation, there is a configuration file that is connected to this. And now in that configuration file, it states when the different alerts should be triggered and when they should be resolved. And we have the interaction with the muting, acknowledging the alerts, etc. Here is Azimuth. That's the only instrument that we have implemented as of now. For that, we use a lot of time getting a responsive design that you're able to scale it to different sizes. One of the challenges here is that the stroke width should be constant. So if you watch the stroke on the watch face, you see that the stroke is always the same width. And that has implications on the design, since the stroke will relatively increase its size when you decrease the size of the azimuth. So Jon and Kjetil and others have helped changing the design a bit so that you don't get overlaps when you it changes the size here. So that was quickly through the demo. Another developer tool that we have is the Storybook. So the Storybook is used both as a developer tool when you're making a new component. You can see live how it looks, but also meant for a documentation of the components. Yeah, so here you can see the code. You can see how to use the component. You can see what properties you can set and what the value can be. And yeah, here see the alert, mute, acknowledge, turning on and off different features. We also use this as for snapshot testing. So all of these stories are taken a screenshot of. So if there is a modification of the look on any of these stories, then the build will fail. So that's a safety net when you're doing modifications of the CSS. We've also exported all of the icons from Figma. Here you can search for the different icons. It's also two different ways to use colors. Some of these icons have two colors. Then you use the colors from the palette, while other have only one color. Then you can set the font color or the color properties in CSS. The icon will follow that color. Yeah. Then I'll jump into more implementation details. How are these components implemented? Start with these buttons and navigation components. Here is the app button. And as you see, there are multiple stories on the left, on the right side here. You have like normal, regular way. You have the checked state. You also have different sizes, small and normal. So all of these components are implemented with the same structures. You have one folder per component. There are 3 files following this naming convention with a component file with or a TypeScript file with the lit implementation. You have the CSS, and then you have the storybook. In the previous implementation, we made one large CSS, which all components use the same CSS. That we have abandoned this time. Now it's rather one CSS per component, and the global CSS should only be used for palettes and color variables. Here is the same app button. It's structured by first importing the CSS that's injected here. We have a template, which for those who use React is quite similar to the React syntax. You set the properties like this. In the previous example, the code wasn't that well documented, but we use the documentation or the comments to generate these wrapper components. And the generation of the wrappers are fully automatic. Most of the features are detected automatically, like properties and slots, but events are not detected. So these must be documented. Part of this documentation is also visible in Figma, no, in Storybook. For the CSS, we use post CSS to post-process the CSS. Here, for instance, we use nesting. Nesting is now a part of CSS standard, but using post CSS is now flattened to conventional style or earlier way of doing it. But here is a new, this is not standard CSS. So we have made different functions mixing for common things. So here is a style by using this function called style and setting style equal to normal. We get the background, get the border, we get pseudo elements or pseudo states like hover and active or pressed or disabled. So here you can use all of these states or all these themes that are used in OpenBridge, like normal, flat, indent, and raised. And you've got all the backgrounds and all you need. Instruments are a bit different. With the components that I've shown earlier, it's mainly HTML and CSS, while with instruments, it's heavily on SVG. And earlier, I made an exporter for SVGs where it can link to a Figma file and get out SVGs. What we have seen is that with a new focus on responsive scaling, responsive design, then then the exporter didn't work that well. So instead, we just copy the or export the SVG directly from Figma and insert it here. You need to do some modification, like setting the stroke to the CSS properly instead of the hard-coded values. You need to set the vector effect equal non-scaling stroke on all stroke. That is to make sure that when you're scaling the component, the width of the stroke is always kept the same. Last, we also wanted to clean up the code or make it more readable. So instead of trying to make one large SVG, it's easy or better to split up each part of the SVG and give it a name so that you understand what this part of the SVG does. And then you can combine SVG's elements into larger components. So get a question, are you only using SVG-based icons or are also font-based icons? The icons are only SVG-based. Yeah. Wrapper libraries. So we tested out early in this implementation to use web components directly in Vue and also React. What we quickly saw then was that autocomplete isn't working very well with web components and type checking isn't working. So I'm lazy and I'm not good at remembering things. So when I don't have autocomplete, I'm always need to go back and check what was the name and what was the magic word for different properties. So I think people making lit also have the same problem and see the issue. So Google through lit has make a prototype or a lab package that can generate wrappers. So these wrappers, it's just run a script and then you get all the wrappers out. And then when you use these components, they feel more like Vue components or React components. You get the autocomplete and you get the type checking. But these are still in a prototype phase. So there are some issues and I needed to go make some workarounds to get things working. But I still think it's worth it. It's a much better developer experience using these wrappers than using web components directly. When that is said, it's also a trend now to do this in through the IDE. So there are plugins to Visual Studio Code, for instance, where you use JSON schema generated from the component library to some add-ons to Visual Studio Code to get the autocomplete. Yeah, but I prefer this wrapper libraries instead. Okay, using the libraries. Now we have updated the README files on the NPM packages. So I would recommend looking into that. Here are some screenshots from that. So you start by installing the packages, either Vue or React or plain web component. And then you need to import the CSS variables into, or you need to import them globally. You need to set the theme by setting this data attribute at the HTML element, then the correct CSS properties are chosen. You need to install the font, Noto Sans font, that's included in the repository. And you need to, yeah, then it's more or less you set up the library, and then it's just to import the component as any other, and use them as a Vue component or React component. Yeah, developer environment. I've been using Visual Studio Code dev container. So now it's, if you would like to use, if you like to contribute, if you like to get the storybook running locally, here's how to do it. I've been using Visual Studio Code dev container. Then you're running your IDE inside a Docker container, which includes Node installation and plugins. So by opening the project and opening it through this command here, you have everything installed. Then you can just run yarn storybook in this package OpenBridge Web Components and yarn dev in Vue demo package. So then I'm more or less through everything. So how to contribute? Please contact us on Slack. That's the best way to get in touch with us. We have now made a new channel. I think it was posted to the chat as well. So here, if you have any question, if you have any positive or negative feedback or constructive feedback, please let us know. We'd like to have feedback on how it is to use the components. We'd like people to contribute with new components. The documentation haven't gotten that much love, so contribution there are very welcome. We also would like to have feedback on the implementation choices. Do you see any performance issues in the way things are implemented? Or is there anything that can be done to improve the developer experience?